All right, Algebra 1 students, this is some video lessons regarding Chapter 7, which is all about exponents. Now, from prior classes, you should have a pretty good foundation on basic exponents, but in this chapter, you're going to take exponents to a new level of sophistication. But I want to review the basics that you should know. So here's a quick review. Here are 3 or 4 examples here of an exponential expression. And so you can have the exponent have both numbers, they could be both letters, or they could be one of each. So this first one is 3 to the second power, or we'd usually say 3 squared. The second one we'd say 5 to the m. The third one we'd say b cubed, or b to the third power. And this last one we would say m to the w. So you need to be comfortable that sometimes the base will be a variable, sometimes the exponent will be a variable, or sometimes they'll be both variables or both numbers. As we progress, I want to show you just some basic vocab you want to know as well. So when you have an exponential expression, which is the entire statement together, the exponent is the small number or variable that would be written elevated above the base value, and the base value is the larger number or variable at the bottom. And together they form an exponential expression. Well, it's really important to know that when you get to exponential expressions, the exponent is communicating to the base. It's always telling it a message. And in this chapter, you're going to see the variation of those messages. But for the most part, an exponent is communicating primarily one thing, and this is what you would have seen in prior classes. That thing it's communicating is how many times the base is represented for multiplication. Now, that exponent needs to be a number in order to do that. If it was a variable, you can't do that. But 3 squared, or 3 to the second power, this exponent is communicating to the base. It's saying, hey, base value, you represent yourself twice for multiplication, and we would expand this and we'd say, oh, well, that's 3 times 3. And 3 times 3 is equal to 9. And that's an old problem you probably have down. Just another quick example, we might say, we could reverse that and say, what about 2 to the third power? We'd say, well, the 3 is communicating to the base, multiply yourself 3 times, or represent yourself 3 times in multiplication. So 2 times 2 times 2, and we would get 8. These are the basics that you should know from prior classes. Now, the 2 other things that are going to happen that you probably aren't comfortable with or know much about yet is that the other thing that the exponent can communicate is about location. And what we're going to see in this chapter is sometimes that the exponent will be a negative number. And what that's going to give you information about is where to move the base to make it positive. Because we actually don't know how to do negative exponents. We can only do positive ones. So we have to move them to where they're positive. Most of the time we see positive exponents, and that's what you're used to, but you may not realize they can be negative. So there is a location message, too, that we cover in chapter 7. The third thing that can happen is there's a connection of our exponents. There's a connection that can be made to radicals, and that's going to be later in the chapter, and that's something very few students see prior to Algebra 1, but that's what we're going to go over. Now, there's a couple basic things I want to make sure everybody knows. And up top here, there's a couple implied things that I want to make sure you know. That first thing is, if it's not written, the exponent is implied to be 1. So when you see 5, 5 is really 5 to the first power. Or for any real number, n to the first is equal to m. You learn that usually early on. And so we seldom write that 1, but it can be written if necessary. But it's just implied. The second thing is, how do you handle 0? Well, when 0 is in the base, there's 2 possibilities. It could either be 0 or it could be undefined, so I want to go through those. If the 0 is the base and your exponent is a positive number, 0 to the third, or 0 cubed, is 0. The 3 is communicating to the base to multiply yourself 3 times. Well, you would have 0 times 0 times 0. Well, that's clearly 0. But a more generalized form is 0 to the n is equal to 0 as long as n's a positive number. If the exponent's positive, you're just going to be 0. The other thing that can happen is that 0 to the 0, though, is undefined. And this we discuss more in Chapter 7.1 lesson, but this is old material. Some of you may be thinking, well, anything raised to the 0 is 1. We review that as well. But when the base is 0, and that's all this little statement is about, there's 2 outcomes. When the base is 0, if the exponent is positive, it will be 0. If the exponent is less than or equal to 0, it will be undefined. So it depends. You got to be really careful when you look at these. And what's going to become more common as your math career goes on is there's going to be little clarifiers about what's the world that the exponent or the variable comes from, knowing whether it's a real number, integer, rational number, natural number. But for any positive number, it'll be 0. Anything 0 or negative is going to be undefined. The other thing is, really important, it's really easy to make a mistake here, is what we have on implied parentheses. There's a big difference between these two questions, -5 squared versus -5 squared. Well, this -5 has parentheses on it. This exponent here is communicating to the entire statement in parentheses. So this is going to equal -5 times -5. Well, you know that two negatives in multiplication become a positive, so this would equal 25. That should be good. But this is the one that really confuses many students. There's another one of these places where there's a 1 that we have not written here, and it's this one that will confuse you and cause a lot of errors, and you can miss a lot of points on this one. This statement right here, without parentheses, that 2 is not communicating to the negative. It's only communicating to the 5. And so what I recommend students do is that whenever you see no parentheses here, that this is really equal to -1 times 5 squared. That's really what the question is. The 2 is only talking to the 5, so this question becomes -5 times 5 times 5, or -1 times 25, which is equal to -25. So you want to notice that in one situation you get a -25, but in this situation you get a +25. This is probably the most common error I'll see with students in Algebra 1. So quick recap, we should know how exponents work in general, the exponents communicating to the base, and we're going to go over this chapter, some more sophisticated levels of communication. But here's the biggies that you should know coming in. If not written, the exponent's implied to be 1. What is the simplification when the base is 0? Well, there's two possible outcomes. If the exponent is a positive number, it'll be 0, but if it's 0 or negative, it'll be undefined. And then the implied parentheses here, this is a really important one to have down, that -n squared, I'm going to put this one here, -n squared is equal to -1 times n squared. I'm going to scoot that over just a little bit. -n squared is equal to -1 times n squared. Hopefully we can fit that in there. These are the biggies that you want to know before we progress. All right? Quick review, and we'll see you in the next lesson. Thanks.